Hi, I'm Tom and I talk about code. Welcome to another Rust programming livestream. Today, more work on my compiler, and we are doing structs. This is monumental. This is huge. This is such a significant step in making my programming language a language which can actually do things. And it's going to be really complicated. There's a lot of stuff we have to make happen before we can get to structs. I think a good way to start this stream is for me to say a few quick things about what structs are and how they work, right? So you define a struct. You're like, you're in C or your favorite programming language. You say struct. You do some curly braces, you give it some fields, like an int called x, and maybe like a float. Now my computer doesn't have floats, but let's say we have a float called y, and other fields, and you define a struct, right? So we have these things in our struct that basically offsets, right? We're going to have some structured data. Eventually, this is going to turn into a pointer, essentially a void pointer. And then we're going to treat these things as offsets, where, the field x lives at +0, and this lives at, +2 or +4 or something, right? We have this idea that we have a thing with fields in it, but when we compile this, we bring these down into their most essential element, which is an offset, a numerical offset, because structs, as magic as they may seem, are really, really similar to pointers. All of the work I've done in the last few stream on pointers is going to come back today. If this doesn't fully make sense, hopefully it will by the end of the stream. And I think the first thing I need to do to really get structs working is to actually have user-defined types, because otherwise, every struct is a user-defined type, right? We're adding a new type to the compiler that has a bunch of data associated with it and a bunch of magic. So we definitely need to handle that. Okay, we definitely need to have user-defined types. So we're going to do something that isn't 100% structy, but it's going to be our starting point. And it's going to kick everything else off. So we're going to make a branch, git checkout. We're going to make a new branch. We're going to call it struct, which is really exciting, really exciting. We're going to need a new top level element. So we're going to go into our AST. We're going to go into our top level enum, which is defined somewhere up here. Okay, and we're going to have a type. Oh no, sorry, that's expression. Where am I? Enum. I went past it, right? Top level. Enum. Top level. I went past it. That's fine. I wasn't really paying attention. We're going to have a type definition to go alongside our function definition, right? And a type definition is going to be like a function definition. It's going to have a type name. And it's going to have, I guess we could call it an alias or an underlying or something, right? We can call it type definition, identifier. We'll have, maybe let's say alias, and this is a type, right? So we're saying that this thing is equal to another type, which is excellent. And then we're going to make our struct definition parse into a type. That's what I think we're going to do. We're going to go, this is basically what Golang does, right? Where a struct, let's, open a file. Let's pull up our test file, because we'll do everything in here. As per usual, we'll do everything in here. Just having this useful scratch file, right? We'll do everything, in one place. So you can kind of say type foo equals int, right? Except we'll probably use colon equals, as is the style of my language. But then you can also maybe say type array equals struct, and you have a pointer, semicolon, comma, maybe comma, and a size, right? Something like this, where you can use a struct in place of a type. That would mean you could do other kooky things, like have a function where you say, struct int x foo, or I guess bar. You could pass an anonymous struct definition as the type in a function call. And I don't think my language will really make sense of that, but I guess in theory you could, even if it's invalid. Or I guess you could do it, it's just you couldn't actually, there would be no square pegs that would fit into that square hole. That would be kind of like making a star-shaped hole, and there are no star-shaped pegs that would fit in it. So this is what we're building towards, right? And I'm specifically using, this array because this is the main thing I think we're going to do with this, We're gonna have lists of things, and that's gonna be built on top of structs. I don't know if I'm gonna have native array types, but anyway, that's all neither here nor there. There's a lot of stuff going on. So a type definition, we need to associate an identifier with a type, and that's cool. That's very easy to do. So let's grab, let's go type definition. We need to tell it how to print this out as well, and that is going to be really simple. Write ln. It goes on a new line. We say type, we say name, we say equals, we say alias with a semicolon. Beautiful. We need to add a parser for this. Function definition. We'll put this up here with the other top levels. This file should probably get split out at some point into expressions, statements, and top levels. It's getting quite hefty. 600 lines plus tests. That's maybe a little bit too long for one big file, but again, no rush on these things. So we're doing a type definition. Okay, so a type definition, where the first thing we want to do is try and grab the token type. So skip white space, token type. Cool. And this, of course, needs to actually be called as a function with the input. So we have type, we have a name, which is going to be skip white space identifier. I'm just looking at this and thinking this with confidence is probably unnecessary, but we'll see about that. I'll try to focus on the thing that I'm doing. Okay, so let s2, let name, skip white space, equals, right? So, whatever we printed out here, we need to now kind of do in reverse. We need to parse it in, and then we have the actual type itself. So, we need to call this parse type. And I think after this point, we might actually be more confident. So we might be able to say confidence. We could say with confidence. We could also elevate. Where's an example of elevate? Maybe not elevate, actually. Let's do with confidence. Let's say skip white space with confidence. If we get an identifier, because we've seen the token type, we're pretty confident that we're grabbing a type. And this is just how I I give extra hints to the compiler that, I'm more sure that this error is the one that we care about. So with confidence, in this case, we're probably still confidence. Medium. Typing is really hard when it's this cold. I don't rate this weather. By the time we've seen the colon equals, we're really, really confident that this is some kind of type definition. Okay, so we parse the type, and then we just hand this back out. We hand out, we need to actually define the thing we're giving back, right? So AST top level. Oh no, we don't. We've already got this. So AST top level type definition. We have a name, and we have, I guess we'll call this alias actually. Alias is a bad name because this is the thing that we're aliasing, but we're just going to have to roll with that because that is now what I've committed to. Okay, so this function definition type. Can we build it? Okay, a couple of issues. Expected parser error found confidence error. That's weird. Oh, that's right. Yeah, this already has a confidence. That makes sense. So if I build this, it's similar thing here, same thing here. So this is where I actually need to map the error and elevate it. But I'm not going to do that right now. Oh, and then, yeah, oops, extra stuff. extra cruft hanging around. Someone said in my stream yesterday, you know, the hardest thing is when a bug is actually you just not understanding your own code, and that is definitely what we're verging on here. So expected confidence error, found parse error. This one, however, does need a with confidence. Sorry, gosh, that's tricky. That's tricky. S2 isn't used. Very useful error. Very, very useful error. I love unused errors. Okay, so now when we code gen this, in the first pass, we need to do something here. In the first pass, we need to do something here. We also should probably know if the thing we're doing this alias with is a struct, we might need, do we need to register it somewhere? I guess if the struct is part of the actual type, type. This is hard because the type is called type, but maybe we don't need to. So AST top level, this is type definition name alias. What do we need to do in this case with 2 colons? What do? We need to say, what do we have? Global map. Yeah, that's not what we need. What we need to put this somewhere. We need to put this somewhere that all future code can reference it, and that probably is in the context. So let's imagine what this looks like. Let's say context.define user type name alias. Okay, maybe that's all we need to do. Maybe that's it. Maybe that fixes the problem. Well, not the problem. Maybe that is the path forward. So now let's go into our context and let's try and write that function and see what happens. Well, first off, we're going to need somewhere to put this. So let's call this type. Let's call this user types. Okay, and this maps from a string into a type def. Maybe just a type. Maybe just a type. What does a type look like? So is this where we put struct, you know, which is just a vec of struct, or maybe a map, maybe a hash from a string to a struct field, something like this, right? Is this workable? Is this a path to good working structs? Is there a problem putting this in the type, or is this something we want to look up, you know, on the regular? And it's hard to know. When we have a variable, we know its type. So it's kind of like saying, hey, all this struct information, it travels with that type. The only problem I see with this, is that I'm going to come back to this comment in a second. I think this is important. The only problem I see with this, how do you know, right? So if I have a struct foo and a struct bar, and I have 2 variables, actually let me type this because it's going to be easier to see in test.code. So let's say I have this struct, right? And let's say I have a second struct. I'm going to call it type bar equals struct. And this has some stuff in it, right? I don't know what's in it, but there's stuff in it. And let's put a semicolon at the end. I think that makes more sense. Okay, so let's say we have, let's write another function, because let's call it something. And let's say it takes a pointer to an array and a pointer to a bar. Well, straight off the bat, we need something. No, we don't. This is okay, because we can look up this name. We can look up this name and see that it matches to a struct definition. But what if we say, okay, this is kind of crazy. The more I think about this, the more right it feels. The case I was worried about was if you tried to do something like assign foo to A, right? But I'm not gonna support struct assignment by value like this right out the gate, so I don't need to worry about it. If I want to support this eventually, how do I know if these things are assignable, right? And maybe I can actually do this by comparing the structs. Maybe if bar as a struct has 2 fields, one is a void and one is an int. Maybe I actually can assign these things. I don't know. Maybe I need some kind of protection here in this case. But this is the kind of this system, this pathway is kind of painting myself into a corner where this world, like it kind of makes these things assignable. It makes it harder to differentiate them unless you differentiate by name, which I don't want to necessarily do. And this kind of gets into the concept of a type alias versus a new type, and Haskell kind of has this. Not every language does. Okay, so we have this question: isn't it a map from a string to type? And I think this was in reference to this part of the definition of a struct as a type, right? Where we map from a string to a struct field. And the reason that this doesn't map from a string to a type, because if you think about what a struct is, right? In my example, you have a name and then a type, right? So what is the extra data? Why do I need this to be a struct field? And the answer is, where does the data live, right? But this struct, say in this case, let's go back. So a void pointer, this is a 16-bit number for now. It may not always be a 16-bit number, right? And then we have a size, which is a 2-bit number. Int is 16 bits in my system. So, essentially we have this blob of data that is 6 bytes in size. So when if we look up, for example, a dot pointer, we need to know that lives at offset 0. When we look up a dot size, we need to know that lives at offset 4 or 2, depending on how big a void pointer is on this given day. But we need more information than just the type. We need to know what offset it's at as well, and maybe some other data too. I'm not totally sure yet, but definitely more than just mapping from a string to a type. Cool, awesome. Sorry, hopefully that wasn't too much of a journey to get to that question. It's a good question. It's a very good question. It's a question that I was asking myself while I was typing it. So let's go back to context. Define. Oh yeah, we haven't written that yet. Okay, so we have the user type struct, and then we need to write define user types. And that can go somewhere in here, right? So we'll say pub fn define user type, mutable reference to ourself, the name of the type, and the type that we're aliasing. Weirdly enough, this is the same as defining a global. It just, has a very different context, a very different kind of resolution. So we say self.usertypes.insert s.toString, and then the type, and we actually it's been moved here. So what we probably want to do is take a ref to a type and then clone it. Because we want this map to own this data, it gets really messy if we think about this map not owning this data, right? This type comes from somewhere in parsing land, and now it's coming into compiler codegen land. The codegen actually needs to own this type. It needs to own the name of it. It needs to own the thing. My maps aren't always maximally efficient when it comes to how I handle these strings, but in this case, this should own everything. So, define user type. This is good. This is good. And then if we see it in our compiler parse, this is cool. This is my favorite bit. If we see it in our compiler parse, we ignore it. We do nothing. Okay, because this is a 2-parse compiler. So we define the user type the first time we see it, and then we just ignore it from then on out. It's beautiful. It's a thing of beauty. So if I build this, it's going to work. Once I import the right thing, once I import hash map, what else do we need? What else do we need? Struct field is not defined. Let's go type struct field equals, and it's going to be a type and it's going to be a u size, I guess, because it's just a type and an offset for now. Might become a structured type in its own right later, but for now we're just going to go with that. Okay, expected resolve type found AST type. Yes, yes, beautiful. We can dot into this. And I think this still probably will have some problems. This we have to borrow like this. This is annoying because this is a ref to an AST type, and we can't into it for some reason. I don't understand everything about from and into, because Rust is hard. So there's some restriction here that I don't understand, right? I would think that if I had a ref of a t, I could call dot into and get a ref of a u as long as the from and into were implemented correctly. I would think that was okay. But apparently not. So I guess what I can do is this, which feels really dumb. Or I guess alias.clone.into and then take a ref of that. In this case, let's just make context actually take ownership of this thing though. Then we don't have to clone again. And that's consistent with how we use it. Okay, so type definition, yep, we just want to ignore everything in there, like above. Type struct, okay, so now because we've defined the struct type, we actually need to do something with it, which is cool, Okay, so what have we got? Struct. Well, we need to know how to display it. Now this is going to be a little harder. Self struct. Okay. And a struct has fields. We need to say write. What are we writing? We're writing struct. And then all of the fields. And then a semicolon. On different lines. Where this thing, well, first off, actually, these need to be double curly braces because we need to escape them because that's how Rust works. We need to get all these fields in a list. So we go fields.iter .map. So we're going to turn a name and a type and an offset that we'll ignore. We turn that into, we format this into a string. And actually, no, let's do it like this for now. We're going to need some new lines, okay? This is going to be a spicy line. This is going to be a long line. We can just do format. I don't like using format inside of this. It's a little bit silly, but that's okay. It just makes things a little simpler. We get the type and the name. We're going to collect. We're going to put this on a new line as well because this line is going to get crazy. Let's tab you in. Iter, this needs. Okay, collect. We're going to collect this into a vec of something. It'll be a vec of string, but we'll just say vec of something. Then we'll join it together with comma new line. Beautiful. Beautiful. And then actually, we don't even need the curly braces because this is all just a single statement. And when we build this, it almost works. It almost works. Oh, because I forgot to close my my lambda capture lines, of course. That always happens. Okay, a couple of other places that type struct is not covered. Now, size bytes. This is another fun one. Struct. If we look at the fields, we're going to write another fun statement. We're going to say fields.values. I believe this is the thing we want. Let's rust up doc. Let's grab the docs. Let's go into hash map and remember what this iterator is called. Because I can never remember. I have to look it up pretty much every time. Values gives us an iterator, visiting all values in arbitrary order. Beautiful. Okay, that's what we want. So values.map, we want to map our values. It's a type and it's, so it's a type and it's an offset that we want to ignore. The offset doesn't matter here because addition is commutative. And then we just want to give back size, the type, the size of the nested type. Cool. And then we want to sum. I think we should be able to say sum. Let's find out, but we should be able to say sum. This statement's not surrounded by a body. Yeah, because I did it wrong. Map. Expected closure that takes one argument. This is a tuple. So we can just wrap it in things like that. And that does in fact work. So that's the size of a struct, right? That's kind of beautiful and elegant. That's kind of nice. I like this one-liner. It's not my best work, but I like this as a one-liner. I think This is a good start, okay? So we can represent structs in our type system and... Oh no. Oh no, I don't know if that sound picked up. I've got a little tea strainer lid and I just dropped it into my tea. So that's currently... It's gone for a swim. I think I can still drink it. Metallic. Okay. Oh, that's right, yeah. I'm going to make a new type for 4-byte pointers. I kind of rambled about that at the start of the stream. So if that was bothering you from 20 minutes ago, I have a to-do for this. And I'm going to have 2 different pointer types. Okay. So what happens if I try and build this right now? Well, it's going to blow up because I don't actually know how to parse a struct. Lang test.code. It's going to give me some error. Yeah, so it fails at this line, which is what you'd expect. Let's see if we can use this int type alias, though. That's kind of cool. Let's make a variable. Let's say let x well, this is also going to break. This is also going to break. Expected token type. That's interesting, actually. That's not what I expected the error to be, but let's fix this. Because we can parse anything as a type. We're allowed to parse anything at a type, as a type. Parse type. Actually, hold on. I think there's something else I'm missing. Where are we? Type definition. I forgot a very important thing. I forgot that we also have to end this with a semicolon. Token. We also have to end this with a semicolon. If you're new to this journey, you haven't seen my fantastic written out monads before, I'm very sorry. I'm very, very sorry. Okay, what does this say? At dot size. Dot size. Yes, excellent. Well, that makes sense because that was not a valid thing. So, okay. This is what we expect to see. Near and far pointers, my beloved. If you've done any old school DOS dev or anything, near and far pointers, it should make you sweat profusely. Oh boy, it's gonna be fun. It's gonna be fun. Okay. So, we get unimplemented, which is good. We say foo is a user type, but we don't know what to do with it. We fixed this last stream or a few streams ago. In the AST, we made it so that you can actually... where is this? Type into and from. Was this? Well, maybe it was in resolve. Yeah. No, hold on. Wait, where was it? Where was it? To do? Here, yeah, this. So we represented user types in the AST, which we hadn't done until very recently. But now when you try and convert it into a type, it blows up. So what do we do with this? What do we do with this? This is actually tricky, okay? Because suddenly looking up a type is not so simple. You actually then need the entire context to do the type lookup, and this is now something that could fail. We're not always going to be able to just look up an arbitrary type, and that's kind of tricky. And we definitely need this to return something. So we're going to have to change how this works. This is no longer going to implement from. Because basically we need to add something else. We need to add a context. We need to add ctx. Right? This is going to have to be here. So we're going to lose some of the magic. And I don't think there's anything I can do about it. Unless... Unless I can do like a pre-processing step for all of these, right? Because in the AST types, we're going to need to add a struct type as well. So maybe after the first pass, there's a way we could pre-resolve types. But I think the easiest thing to do is just going to be to not implement this anymore. So we're going to impl... do we impl type already? We do. We impl type. So let's make a method called from AST. Make it a pub function from AST, and it's going to take a context. It's going to take a ref to a context. It's going to take a AST type, which is going to be an AST type, and it's going to give back a self. This is like a weird constructor, okay? We're going to copy from whatever we had before. We're going to match the value. Let's call this value. I think value is a good name. We're going to match the value, but now if this is a user-defined type, we need to resolve it into a type, right? User-defined types do not exist at a type system level. They are all another type, right? The type foo is an int. They're all assignable to each other. Now, if I want to support types that don't assign, that's a different kettle of fish. That's a very different kettle of fish. Also, this is a bit inefficient because we're going to do a lot of copying of the map that represents struct fields, and that's okay. I think I'm just going to live with that. I think we'll just accept that. If it becomes a performance problem, then I'll do the deferred thing. But for now, I'm going to do the dumb thing, which is just copy everywhere, because I think that's good. I think copying is kind of good. This is my controversial opinion. Okay, so we're going to go context.get. Hold on, sorry, I forgot one more thing. This needs to give us back a result. It's either gives us back ourself or a string. Okay. I guess we'll do string for now. I guess we'll do string. So we'll say get user type, which is going to give us back an option. So we'll say okay or format s. So we either succeed or we give back an error that that contains this thing. So get user type gives us back a type. So this is good. This is correct. This is what we want. So we're going to get rid of from. This is going to break a bunch of stuff, and that's okay. We're not scared of breaking. Nice, okay. Into. So now we need to say type from AST. So annoyingly, this is actually quite a bit of typing, but we can get rid of this type hint, which is cool. That's kind of cool. We'll say type from AST. So we're just gonna have to do a bit of grunt work here. Okay, there's gonna be a little bit of grunt work. That's okay. That's okay. We couldn't do any, like, even an LSP. There's a lot of LSP people who are atting me, who are in my DMs. Even an LSP wouldn't help here. Yep, this is going to be the same thing. So type from AST. I think we still have to clone there. Oh, actually, do you know what I can do here instead? From AST, I can actually pass a ref to a type, which might actually be better. It might actually be a lot better. Because then I can just do that. Right? I don't need to do these clones unnecessarily. It essentially clones the data under the hood anyway. So that's kind of a benefit, actually. I talked about this previously. I talked about this in some previous stream about how I wanted to pass refs. So that's good. That's good. That's kind of a sign that maybe this actually has merit to it outside of just solving the current problem. You could also say that perhaps the AST types live far too long. They are in too many places, and that would be valid as well. Maybe by the time we get to this part of compilation, we should have converted all of our AST types into other things, and that would be extremely valid. That would be very, very valid. Okay. Oh, into. There's an into, like, right here. What the hell? One snuck by under my nose. So this is going to be, again, let's say self from AST. Right, and because this is a ref, this is a ref, this is a ref, that's okay. Except we need to pass in the context as well. That's what I forgot. That's... Okay, so everywhere we have from AST, we just need to send in a context along with it. And it's just a borrow, so this should be fine. This should be fine. Context. What else have we got? There's gonna be more. I know there's gonna be more. Unnecessary parentheses, love this. Good suggestion. Good suggestion. Expected type, found type, so we can, oops. We can just do a ref here. Yeah, of course. Map, we want to turn this into, so actually, you know what? I think this shouldn't return a string. I think this should actually just return, if I go back to resolve, instead of a string, maybe this should just return a compile error. And we'll make a compiler error called unknown type. We'll just say, hey, what the hell's going on? I don't know what this type is. Compiler error, it is with an R. So we're gonna, instead of this, we'll say compiler error, unknown type. I don't think that works. I don't think that works. Wait, what is this? Okay, or? Yeah, no, okay, or we just give it a value. It's not a closure. It's not a closure. Unknown type. We'll just make a copy of it. Again, I'm not super concerned about copying in this case because we can just blow it up. Okay, so type. We just need to put a bunch of question marks in now, which is cool. Very easy to do. Oh yeah, I need to make that function called like get whatever, get user type. Oh, we need to actually borrow this a few places. That's funny. From residual. Oh no, this is inside of a thing now. Okay, so this is where, oh, this is where this hurts. This is where this one really hurts. How do we do this? We can't return an error inside of this closure inside of the map. So I guess we could do that outside, right? We could build this list out here. We could say, we can say arg names. Yeah, arg names. Oh, what is this? Args typed equals. I guess we could also just call it args. Let's call it args typed because the outside one is also called args. What's going on here? I don't know. Args typed. So that kind of fixes the problem, right? That kind of fixes that problem. We're going to see the same thing again because we do this a lot. Oh no, wait, we don't fix the problem. We don't fix the problem because we're still inside of this closure. That's not what I meant. What am I trying to do? Do I have to do this with a for loop? Hold on. I was pulling this out so I could play around with it more, but actually, let's turn to Google first, okay? Because someone in all of Google, someone must have solved this. Someone must have encountered this before. Rust, function, Rust, throw error inside of map closure. Someone must have written about this before. What's the proper way to bubble up errors from within a closure? It would be great to have a function that was like map with error, right? Nice. Pingu exor. Pingu exor. That's a fantastic username. Welcome. Thank you for stopping by. I'm glad you're a C purist because I'm writing a C-like language. I'm just writing it in Rust. I love C. I want to write C. I just want to write my own C, and I'm doing it in Rust. You don't deal with shit like this in C. Oh my god. Can I not just... Oh, hold on. I can do this thing, though. I can do this thing where we return... It's annoying. If this was... if I was mapping... Do I really like your username? Yeah. Is there a reference I don't get that I should? Should I not like your username? Pingu's great, and Digital Logic is great. This is a combination of two fantastic things. Big Pingu appreciator. Yeah. Okay, hold on. What am I trying to say here? If I was mapping from this into a vec of result t, then I could collect into a result of vec t. So if I do something funky here, I can still make this work. So let's do this. So I'm mapping from a tuple into a tuple, right? Pingu is your name. Wow. Sorry, are you named after the cartoon penguin, or is this like an actual name in a part of the world that I don't know? Sorry, I hope you don't think I'm making fun of your name. I hope also that you know the animated penguin that I'm referring to, or the claymation penguin. Don't look at your generated C code. Why are you generating C code? C is a valid compiler target. Like Scheme has done that to great success. But yeah, Pingu is an actual name. That is a good learning for today. If all my struct stuff falls apart, I learned that Pingu is a real name. Thank you. Thank you for stopping by. Sorry, I really hope you don't think I'm memeing on your name too much. So I want to match the result of trying to turn this into a type, okay? So this is the correct incantation, right? We're gonna match this. If we get a type, then we want to give back name.toString, and actually we want to give back okay. Actually, we can do this better. We can say type.fromast.map. We can map the resulting type into name.toString and the type. And then if we get an error, we get an error. That's it. That's all we do. So actually, this is still quite simple. So now we have a vec of result t, and we can collect this into a result of vec and whatever error happens to come out, okay? Then here we can unwrap that. That's how we can do it. You were thinking of changing your username. I mean, it's always valid, but I think that is a cool combination of words, of characters. EXOR is probably my favorite logic gate. I don't know if other people have a favorite logic gate, but I think other people should have a favorite logic gate. How is Rust? Rust is like this. You've joined at the perfect moment to see what Rust is. Okay, so expected context compiler error. But what did we get? Okay, so we have a context as well. This is somehow wrapped in a tuple, which isn't right. So let's say, what does this return? This returns compiler error. It should be a vec of. Let's be more explicit in this collect, because that will give us guidance. So this should be a string and a type. That's it. That's all we expect to be in this vec. Okay, from compiler error is not implemented for. So why do we have extra stuff here, which is required by result from residual? So why is there extra stuff from AST? From AST should just be a result. So it should be a vec of result string type compiler error, right? It should be a vec of result of this. Is that? Yeah. A result of this. This is a bit of a puzzle. This is a bit of a conundrum. So yeah, Rust is like this sometimes. You get these big compiler errors when you try and write clever code instead of just using a for loop. But I really like Rust. The type system is really good. The Borrow checker forces you to not do stupid stuff. If you like C and you can think about memory in a very C-like way, I think the transition to Rust is simultaneously hard and easy, right? On one hand, it's really hard. There's a lot of stuff you have to onboard your brain to think in. But if you're writing good C code already, you kind of already think like that. You just have to be explicit in a certain way that the borrow checker approves of. And you won't be allowed to do things that you do in C. But if you're good at C, I think you know the risks associated with some of these things. It's just instead of having to make like user assertions, like programmer assertions, to make sure that you're not left with dangling pointers or you're not mutating things at stupid times. The borrow checker enforces it and yells at you and tells you your program's broken when you try and do stupid stuff. So it's good. I like it. I don't know if I would write another compiler in Rust. But for some things, I'm definitely going to reach for Rust. I like having it in my tool belt. So, context compiler. Oh, wait. This actually does return a context. So I need to map the error. I need to map and I just give back a copy of the context, right? Context compiler error. So I give back context error. I forgot. Again, we're back to this thing where the only bugs are me not understanding my code properly. Fit Rioter, welcome. How you going? Welcome. Streaming at a slightly different time again today. I don't know if I stream so ad hoc, I don't know if I can really say they're at a different time because I just don't have a regular time. But it's cool to see different people swinging in when I stream during the day more. Okay, here we go. So this is the same thing. We're going to have to do this ungodly thing that we should not speak of. I'm going to just clean up these type hints so that it's hopefully a bit more flexible. Nice. Okay, that's good. Let's do this same thing here because this is literally the same calculation. Cool. Beautiful. From AST, context. Cool. Yeah, we have to look up the type because we could say type X equals type Y, where Y is also a user type that we have to look up to do this mapping. So the whole tree of mappings does not exist at compile time, and I think that's okay. I think that's fine. Cool. Name alias. So we need to deal with these errors as well. So we need to map this is annoying, but we'll survive. CTX E. Is this enough? Brackets, no. But then we also need this to return, bubble up the error, map, error E, CTX E. With the question mark. Okay, here we go. Question mark can only be applied to values that implement try. Cannot be applied to type. Oh, yep, that's because my brackets are wrong. That's okay. Move occurs because context does not implement copy. I hate this. What is going on? Oh no. No. This is bad. This is really bad. Can I just clone? Can I just say clone? This is really annoying because you would think that you were allowed to do this, right? You're like, hey, yeah, cool. If there's an error, then we're going to make a copy of the context. But actually, because of how this closure works, it still captures over the value of CTX, even when we don't hit the error case, right? We know that we would hit this error case. That would be the last thing we'd do with context. But because of how this closure works, it still takes ownership, move ownership of the whole thing. So we can't use it after this. So we have to clone this everywhere. I think I already encountered this, and I think I already wrote a bunch of clones. And again, right, this is the error case. We only actually, this closure might capture ownership, or it might kind of, break ownership in this way. Capture may be the wrong word, but, it stops us doing anything with ownership of context after any of these closures, but we can just indiscriminately clone it, and that's cool. And we don't care because it's the error case, right? This could be actually quite a large structure to clone, but we're happy to continue. Where is this? We're happy to continue to clone it because we only do that in a bad case. All right, expected result resolve type compiler error. Yep, that also checks out. We need to just wrap these in OKs. Okay. And this is also A-OK. But now this needs to get a question mark. Nice. Now we just don't have a function called getUserType, which is really easy to deal with. We jump into the context, and we say pubfn get user type. This is gonna just take a normal ref to ourselves. It's gonna take the name of the type that we're getting, and it's gonna give us back an option type. And this is just self.usertypes.getS. It's just a very thin wrapper over this map. Resolve type. Found an option with a ref to type. That might be okay. That might be okay. I don't know. Hilariously forgot to actually provide a thing here. This doesn't work because we're trying to give back expected result type, found result type. Okay, so we need to map inside this option, and we're going to say x.clone so that we go from a ref into an owned object, and now we're good. Now we're good. This is why you like explicit captures. So explicit captures wouldn't solve that problem. The problem isn't that the captures are overzealous. It's that conceptually, where was that? Was that in CodeGen? Yeah. It's that conceptually, the fact that this closure exists, right? But because it's a static language. If this is dynamic, then we can say, hey, okay, this closure only exists when we execute it. But because we're static, the existence of this closure potentially being executed means that we can't do anything with owner of context after this point if this takes owner of context. So this was correct. It was capturing in the correct way. It's just a fact of static languages. Like in a dynamic language, that wouldn't be a problem if you wanted to do this kind of really strict checking, which maybe doesn't make much sense. But yeah, you know, the problem is just that we potentially move context there. We may move it. If we encounter an error, we move it. And then it can't use the fact that we immediately resolve it with the question mark operator. Like it doesn't play these two things together, basically. There's no sense of this is the last statement maybe. Maybe there's room for the compiler to be smarter about that and the borrow checker to optimize that kind of thing. That might be cool. But short of knowing that in this error case, this closure is the last thing that runs in the function, you can't really do anything about it capturing the context. Cool. Is Rust better than C according to my experience? There are people who haven't used Rust and still blame it. Is Rust better than C? No. Is C better than Rust? Also no. They're different tools, they do different things. I'm sorry to be uncontroversial, sorry to not have a hot take, but really, like, learn C and learn Rust and use them for different things. Rust has a much better standard library. I think if you're doing API style stuff and you really need that correctness, I would reach for Rust over C every single time. Could not imagine writing a web service in C. That sounds like a nightmare. Rust has a really good package ecosystem. It has really good dependency management compared to freaking CMake, right? If I, you know, like, not having to use CMake makes me enjoy using Rust more than C, okay? The tooling around Rust is really good. Cargo coming with a good formatter. Clippy is really good, like the code quality tools. You know, the kind of things that make C good, right? Like C with a good formatter and a good, what are they called? Like a code quality check and everything. C can be really nice. You use Valgrind to look for memory errors, right? The ecosystem that's built around C has made writing C a lot better, but Rust comes with tooling that gives you safety out of the box, and everyone uses them all in the same way. So that's really nice as well. But yeah, I think if I was doing hackier, smaller projects, I would definitely reach for C. If I wanted really to be sure about correctness, then Rust is definitely the way to go. Rust has a borrow checker and a smell checker. Yeah, definitely. Okay, so that builds now. And what happens when I run it? Oh my gosh. So we actually compile some code there, which is kind of cool. You think C can never be replaceable? You're absolutely correct. C is not only a language, C is like an ABI, right? C is the language of Unix. Rust interrupts with C, right? Of course it does. It has to. So yeah, there'll always be a long tail of C code that will never go away, and there will always be value in being able to write C. It talks very directly to the machine in a way that Rust can as well, but like Rust just has a lot more stuff you need to have in your mental model. Is Rust better than C++? Absolutely. I will say that till the cows come home, but Rust and C both fit different niches in my mind. And PinguEXL, thank you very much for the follow. Okay, so let's have a look at what is being generated. What is going on with my keyboard here? What am I pressing? Okay, so what instructions does this generate? It generates the same instructions as if it was, what does it do? It puts this into the A register, which is cool. Yeah, so this just returns the number 5, which is exactly what we're trying to do. So this works, this alias works. C needs absolutely no runtime support, neither does Rust, okay? If you build a C binary on Linux with default settings, you get a runtime. You can configure C to run without a runtime, but you can configure Rust to do that as well. The Rust runtime, like, yeah, I mean, runtime's kind of a tricky word, but C definitely, I mean, that's what CRT stands for in CRT0, right? If you look at like all the linker scripts and stuff, that's the C runtime. So C doesn't need runtime support, but there are other languages that fit that as well if you configure them to do so. C maybe has less overhead to configure it like that. C without a runtime is maybe closer to C with a runtime than other languages. But I don't think it's really a fair comparison to use that as a reason to write C over Rust. Over Python? Yeah, but not over Rust. Okay, so we've got user types. Now we need to be able to parse a struct definition and see what happens. So let's take a quick breather. Let's take a quick breather. And let's jump back over to this, and let's cross off something from my list. Because this is one of my favorite parts of any stream. When I get to cross off a thing that I've done, it makes me happy, makes me very happy. Okay, so we've done user types. Can we parse a definition of a struct? This only took me 58 minutes of the stream to do the first thing. So we're on a roll. We're making good time. I need to quickly just check up on my plans for tonight and make sure that everything is, oh God. I got a really weird job offer. Someone texted me about a job and I was like, hey, what are the details? They were like, you'll be contacted on WhatsApp. And I was not contacted on WhatsApp. And then they just texted me again. And I'm like, okay. This is weird. This is kind of weird. Cool, so we're putting struct inside here. So we're gonna say, sorry, let's do it here. So struct, which is gonna be, in this case, it's gonna be a vec. In this case, it is gonna be a hash map from string to type. Actually, no, it's gonna be a vec because I care about order here. We're going to make it a tuple. Iteration order of hash maps is not guaranteed, so if you care about order, you need to use a vec. And this is fine. Like, there's not actually that many things, and we're never going to look them up by name in the AST, so that's okay. Cool. So if we display it, self struct wait, didn't I do this? Did I do this? Am I going crazy? This is, let me just make sure I didn't already do this. That's really weird. Lang. And not case insensitive. Vec. Oh no, I wrote a formatter in the resolve version. That's right. Unresolved. Yeah, I did it here. So we're gonna do the same thing. The good news is that when we display this, it comes out in any order. But when we do this, we'll get the order we defined it in, which is nice, which is very nice. At this rate, it's going to take 3 more hours. Maybe not. Maybe not. We might have done the hardest part. Maybe actually all that wiring was the hardest part. We'll see. We'll find out pretty soon. Okay, so now we map, but we just map from a type and an offset. Oh no, sorry, we map from a type, from a name and a type to a type and a name. Excellent. Can I build this? Maybe, not quite. Fields not found in the scope. Struct fields. Cool. Now we have a few more things from AST. Do we trust this function to be the source of which offset struct fields live at? Sure, why not? I see no problem with this. Okay, so if it's a struct, then we want to go through, we want to, what do we want to do? I can put a curly brace in here. This is kind of weird, but putting an entire block expression inside of an OK. I don't think I've done this before, but this kind of makes sense to me. So let's make a variable called offset, which is going to be 0. As we add each field to the struct, we increment offset by the size of the previous field. So for f in fields, I think I need to do it like that. I don't know if I need to borrow here because this will already be a ref. Let's try this. So for each field, let's maybe call it field. Let's maybe be even more explicit. Let's say name type. Okay, we're gonna say we'll say out is a hash map, right? Because the struct type really just wraps a hash map. It just wraps up. Just wraps up a hash map. Where are we? Struct wraps a hash map from string to struct field. Okay, so we say out.push name.toString, and then we just put in again. So a type and an offset. So this is the field type, except this is where we need to do this recursive thing. So we say self from AST field type with the context and field type. We chuck a question mark on that, and then the offset as well. Then we increment the offset by the size of the field and maybe align it to 16 bits. This is a lot of logic to put in this conversion now. That's a lot of logic to put in this conversion. Okay, this is okay. We're just gonna increment it by the, what are we saying? Field. Actually, we need to do this conversion first. So we say let tt equals this bit. tt.size bytes. Then if offset mod 2 isn't 0, offset plus equals 1. Right, so we're going to keep it 16-bit aligned. I think that's fine. I think that's good. Okay. And then all we do is return out at the end. This is called insert, not push. That makes sense because this is a hash map, not a vec. Expected type found hash map string. Oh, yep, that also makes sense. So we can actually we can go one step further here. We can say self struct. We can do another layer in this expression onion, right? You peel it back. So this is all just one expression that is the value of out, but we've wrapped it up in a block to do some work. TT has type resolve type, which is non-implement copy. Value moved here. we'll do this increment first so we don't have to make a copy of the data, because again, ownership, we can increment because this size is calculated by a ref of TT, but here we actually move ownership of it into the hash map. Okay, so that's fine, that's fine. That still doesn't do anything, though. That still doesn't do anything. So we can deal with a struct. Now we can actually write a parser for a struct. Parse type raw. Okay, so now we have to get to the real stuff. If we see the word struct, then we've got to do some work. Then we've got to do some work. Then we've got some, oh boy, do we have some work to do. Again, this probably actually needs to live outside of the rest of this, because we can't say struct, then do some other stuff, because we're already returning, like, this S0 up here. This is like the state. The state is based on just taking one word, whereas this struct is going to take a lot more than this. So let's say if res equals struct, do some stuff, else do this. So if we get a struct, then we're going to have to do a bunch more work. S1, we're going to skip white space and grab the token, open bracket. Then we're going to get a list of fields that are separated by commas. List of fields that are separated by commas, fields. And then let S3 cool. So what are these fields? This is the same thing that goes in an argument list, right? So if we just look for a function definition, we can get this, args. Cool. Except now it's called fields. Named arg followed by a comma. Perfect. Perfect. And this now takes S1. So that might work. That might work. And then we just give back OK, S3, and fields. Except it needs to be wrapped up in an AST type struct fields. What does named arg give back? It gives back an identifier and a type. Identifier and a type. What does a struct take? It takes a string and a type. So maybe actually I modify string and a type. Maybe I make this an identifier. An AST identifier. Maybe that makes more sense. Then some stuff's going to break. Unclosed delimiter. That's a really easy one to break. Unclosed delimiter. You're closed. You're closed. You're closed. Where's our unclosed delimiter? Where's he hiding? Oh, there. There he is. Okay. Beautiful, beautiful. Now, of course, we've got a couple of bugs here. From confidence error is not implemented for parser error. Parser error. Yeah, this we're gonna make this a result that returns a confidence error. And just simplifies, you know, less typing in general. Less typing in general. So now, that's actually kind of funny. We don't have any errors here, so I guess that's fine. Confidence error because of this. From parse error. Okay, so this one does just return a parse error. So with this, we need to say with confidence. And this is just confidence low. Similarly, this is going to be the same thing with confidence. That's not the right place for that. Confidence low. This should now be fine. Confidence. Confidence. That's not how you spell. Spelling continues to be a big struggle. Spelling continues to be a big struggle. Okay, so confidence error because of this. Confidence low. From confidence error, confidence error. So in fact, this one is not a confidence error, apparently. This has already been taken care of. Okay, cool. Result, story SD, confidence error, pass type row expected, confidence error. Ah, yes, so now we go down a level. And we don't have to map this anymore. Nice, that's good, that's cool. So what happens if I build this now? It still works because there's no struct definition. I should probably write an actual test for this rather than just doing it ad hoc. So let's go function test struct. We'll do our usual copy and paste job because I love copying and pasting these. Just without the, okay, let expected equal type foo equals, if I can find that right character, struct int x, int y. And then this is just gonna be type definition what happens when I test it? What goes wrong? Okay, we're close. We're really close. But we have to do this. Okay, we've got a couple of extra characters. That's also good. Like this. And then I guess we have to get rid of the white space too. Okay, left. Right has a double semicolon and an extra new line. So we need to put a new line here. Double semicolon. I don't know where that extra semicolon comes from. Is this because when I format a struct, I put a, it is. It's because I put a semicolon at the end. Okay, there we go. So this test now almost passes. Almost passes. We want to go back to language. We want to go to our test. So kind of annoyingly, the last field doesn't need a comma, and maybe it should. Maybe I should require that comma. Maybe that's what I need to do. Maybe. Cool. All right, cool. Sorry, I've just had confirmation from my friends. I've got another hour and 15 minutes. Okay, so it is still struct time. It's always struct time somewhere. Let's rewrite this parser a little. Let's rewrite this just a little. I don't have to delimited. Oh no, hold on. Let's not rewrite the parser. Let's leave the parser as is. Let's rewrite the formatter. AST struct, and let's write the comma into the thing. Now when we make t, this should work. Perfect. Okay, so let's do a commit because we've done quite a bit. We'll add everything. Lang, user types, and structs. Because they all got tied up together, I probably could have planned that out better and had much better atomic commits, but that was a really good start. Maybe I should rewrite that commit message. I'll think about it. Okay, so we can parse a struct. Well, now what do we do about it? Well, we need a new type of expression. We need a new type of expression to reference a field in a struct. And I'll come and draw some stuff about this and talk about this more. But first, I'm going to take a quick breather and maybe refill my tea. I'll be back in a second. Thanks everyone for hanging around. You know what's funny? I forgot to actually make a cup of tea. So that's fun. That's fine. I didn't need one anyway. I just needed to stretch and a drink. I filled up my water. I just forgot to make tea. Cool. Okay, so let's talk about structs, right? I drew a thing at the start of the stream when I was still kind of working out what I was doing. where I kind of wrote this weird struct definition and I wrote these offsets, and we've kind of done this now, right? We've got this concept that a field of a struct is really, you know, if we have a variable, right? If we have a variable, we have some struct foo, and we have a variable x, right? Which is of type foo. I've written that weirdly, but that's fine. We've got an x that is of type foo, right? If we say x dot, oh no, I called these x. Let's call our variable a, okay? If I say a dot x, and that's a dot, not a comma, dot x, what's going on here? What does this mean? Okay? What does this mean? Well, what this means is we take whatever memory address is in A, because A is really just a pointer, in a sense. There's a bit more magic here that we need to consider. As far as my language is concerned, A is just a pointer. So underneath the hood, A is some, 0x BEEO, right? Some magic address. What we're saying when we say a.x is 0x BEEO plus whatever the offset is, in this case 0, right? And then we treat that as whatever type the field is. So at this address, the type of x. If we say a.y, it's the same thing. We would say 0x BEEO plus 4, even though in my language the size of an int is very much not 4. And that's all we do. That's it. There's no magic, right? It's all just addresses. Now, the magic, as far as I understand it, right, because C differentiates. C makes a difference between foo A and foo star A, right? The difference between the value type and the pointer type. And I think this is to do with optimizations around the stack. Like, maybe the compiler under the hood turns a.x into, so if you have a.x, right? If you have some variable foo a that's defined in your function, you have a.x, at compile time, you can turn this into an offset into your locals, right? So instead of a being like a pointer, a is like a transparent reference into other variables that the compiler... It's like a transparent reference into other locals that the compiler can resolve. The compiler can turn this into some special, let's call it x star, because it knows where star is as where x star is as a local. It can resolve it. Whereas a arrow x, because C has two different syntaxes for the value dereference and the pointer dereference, does this thing, right? In my language, I'm just going to treat them all as pointers and do this. Maybe at some point there will be room for this optimization in the future if I know it's a value type. But because I'm not going to be parsing structs by value at first, because that turns out to be not necessarily complicated, but there's overhead, I'm just not going to do it. It's going to slow me down too much. So first pass of structs, they're a little bit dumb. They're just like pointers. At some point, it might be nice to be able to do this value optimization where if I know that a struct, if it's actually a value, and because my language will still have a difference between a foo and a foo star, right? I'll still have the concept of a pointer to a struct. It's just the way the values will be dereferenced will be treated the same until I add a special case potentially for the values in the future. But yeah, copying structs, we're just not gonna do. I think that makes sense. I hope that all makes sense. I hope that sounds like a good plan, and that sounds like something we can work towards. I forgot to commit here, which is kind of funny. Apparently. Is there a problem with this? Oh, it didn't commit because I didn't cargo format. That's good. That's a really good thing. Let's also just make Clippy real quick and see what happens. Huh. Well, this is from last stream. Ooh. Okay, there's some good suggestions here. What's this saying? This is saying get user type dot cloned. Oh, this is a method. That's really good. It saves you using a map. if you have an option T, there's this cloned method that does what I wrote out manually for you. Love it. Okay, so make Clippy. Nice. That was funny. Cool. Bad commit message again, but we'll live with that. So let's go in and let's add a new expression type. This is going to be the important thing because this is an expression, right? A.x, A.y, these are expressions. We can define variables. Where defining a variable that's a struct is actually a little bit hard. So we're gonna need some special behavior for that. What would happen right now if I defined a local that was a struct? Declare. We have a type. So define local. What does define local do for this scope? Next local index. It assumes that all locals are 2 bytes in size. So when we declare a variable, we need to say if t dot if some t was t. Let's type. We'll copy this out here. Except that was too many things. Type from AST. If declared type dot is struct. Maybe. I think that's okay. I think that makes sense. If it's a struct, then we want to return an error. We want to return a compiler error. Actually, no, we don't. We want to to-do. We want a to-do struct value unsupported. Right? Because we just want to say, hey, we're going to do this eventually, but not yet. So now we need to add a method to resolve for type is pointer. And we're going to do the same thing here for is struct. We're going to match self.struct. Beautiful. I need to put my gloves back on. I was a bit keen taking them off. I thought it had warmed up. I might need to put my scarf back on as well. God, it's so cold today. Like the sun's gone down and I can just feel the heat leaching through my walls that have no insulation because it's Australia. You know, we don't know how to build houses over here. If there are people watching from overseas, they're like, why does this guy have a scarf and gloves on inside? Yeah, no, our houses are woefully underprepared for winter. It's pretty bad. Pretty bad. Okay. We need to do this in the other declare as well, because there are 2 different kinds of declaration, one that deals with the value and one that doesn't. Something is t variable type if var type dot is struct. We also need to look at can assign from. We need to look at can assign from because we shouldn't be able to assign to and from a struct. That should be illegal. That should be illegal. So that's in resolve. Where are we? Can assign from. So we want to say self dot is struct. So not a struct and not other dot is struct and not, let's say other dot, let's make a method for it, or maybe matches other void Cool. I think that's a bit clearer. So we can't assign to and from structs. Because that's like a little mem copy, right? That's like copy a little block of memory from here to there if these structs are allowed to be assigned to each other. And that's, maybe we just write mem copy instead, right? Maybe we just don't support that with the equals sign. So what happens if let's have a look at our test.code. So we've got this type foo. Let's make a type, let's call it array. Let's stick to this naming. We'll make it a struct. It's gonna have like I had before, it's gonna have a pointer, and it's going to have a length. Cool. So what happens if I compile this as is? Let's cargo run this one. And that compiles fine. Let's not pipe it into less, because that's annoying. So what happens if I try to make an array? Just declare it. We don't assign anything to it, we just declare it. It says... That wasn't what I expected. Because we should be able to... That should be legal, right? No. Okay, well let's just say this equals 0. Let's see what the error is. Cool. Where do we get the error? Variable already defined x. Oh yeah. Let's call our array y. Cannot declare a struct value, which is what we want to see. That's what we want to see. We can't declare a struct value. We can, however, make a pointer to a struct. And that's okay. And we could actually say that this pointer lives, just about anywhere. We can just put this at like hex 2000. And we could say, well, then the thing we want to do is say y.len. Let's just, assign something random to it. Or let's maybe say make array. Let's just make this a function. It's a function that returns an array pointer. We'll call it make array, and we will return. What will we return? Just a random memory address, right? Because that's all the pointer is, and we have no memory protection here, so we can just make up literally whatever we want here. Okay, so something's gone wrong. Something's gone wrong. Oh, and the thing that's gone wrong is we're not allowed to have underscores and identifiers. I'm going to fix this one day, but today's still not that day. So it's called makeArray. Okay, so now the next thing is we need to be able to say y dot pointer. And actually, maybe before we return this, let's maybe just like set these to something. Out.pointer equals 0x 002 and out.len equals 004, right? So manually doing, wait, equals 0. So the pointer points to the thing after this struct. And we could crunch this down a bit, but that's okay, excellent. So we see that it doesn't understand this dot syntax, which is great. That's what we want. Now, if I look at my AST, assign and assign deref are two separate things. And I might end up in the same situation for... I might end up in the same situation here for structs, because, again, the left-hand side and the right-hand side are treated a little bit differently. Like, when I say this, I mean look up whatever the address of out.pointer is, and at that memory address assign this. Whereas when I say let int x equals out.len, I mean look up the address of out.len, pull out the value of that, and assign that to x. So again, left-hand side and right-hand side are going to be different, and I think what I have to do here is the same thing, where I say assign struct field. I don't really understand how I would do this without making it its own thing. So this is again hard because the left-hand side... So it's easy to imagine parsing this right now, right? Out.ptr, right? You have a variable name and you have a field. But what about when that field is itself a struct and we nest these? So a recursive structure might be nice, or maybe we just have a vec of like field names that we walk. Both these things potentially valid. Both these things potentially valid. So how does resolving this work? We have the type of the thing and we have the thing. We take the field. If it's a struct, that's good. We look up the next thing in the vec. So yeah, so let's say LHS, let's make it a vec of string because these are the things. Let's make it a vec of, I guess, identifiers. And then the right-hand side is going to be an expression. Cool. And that works. I guess that works. And we return out. Okay. I think that works. I think that makes sense. So then we want to go into, well, actually, still in our AST, we need to print this out, don't we? Because if I make B right now, it's going to yell at me about places that I have not done this. So assign struct field. We'll just stick to the names LHS and RHS because I think that's good. Let's maybe say fields. Let's maybe call them fields. Fields, right-hand side. And all we need to do is join them together with a dot. So we'll say fields.join, and I hope this is okay with a dot. If I build this, it'll yell at me about something, I'm sure. Method cannot be called on ref to vec identifier. Because this needs to be not a ref. This needs to be not a ref. Why does this need to be not a ref? Join. Wait, hold on. Can I turn this into a slice? No. No, I can't. Ref to vec. Again, someone must have encountered this problem before. Join over a vector of strings. Join is available. Connect. Okay. Slice connects and deprecated in favor of slice.join. Join an iterator. Can I convert it into an iterator? Does that work better? Wait, method join is available. So what's going on here? What's this? I feel like it's pulling my leg. What the hell? Unsatisfied trait bounds. Identifier. Oh, identifiers can't be joined. Oh, that makes so much sense. Hold on. Whoa. So I need to do this stupid thing. And this is extremely dumb. This is so dumb. Because then we need to collect. This is a huge waste of memory. This is pretty bad. Cool. Now we just need to think about this when we actually see it in real code, which again is a bit of a kettle of fish. There's going to be a lot of code here that's going to be really annoying to write. Statement assign struct field. And we're just going to put a to-do here. We don't need the word unimplemented because that comes as part of the to-do message. Okay, we're making progress. Fields is unused. Let's just put these underscores so that everything's happy. Wait, hold on. That's what I need to do to keep everything happy. Okay, so this runs yet again, and we're going to see, again, we get a compiler error because this does not exist yet, which is fine, which is good. So now we can write a parser for our statement, variable assign, or assign. Let's start with variable assign as our template, and we'll say variable assign struct fields. Just keep adding underscores and names to the things you copy and paste. I think that's beautiful. I think that's the way you really do it, right? That's how you approach life. Excellent. Cool. Okay. So, assign struct fields. We grab an identifier. So this is what's different, right? The right-hand side is the same, but this is where we have to actually grab struct fields. So what do we do? We have to get things separated by a dot. So it's an identifier followed by one or more instances of dot identifier, right? Does that make sense? So let's do this first, right? And then we'll say let s1 fields equals repeat 1. So we want one or more instances of dotted, let's just call it dotted field. And that will return a confidence error. So pub fn dotted field takes an input stir and gives us back a result. And it's going to give us back just the name of the field, right? We don't care about the dots. So let s0, we're going to skip white space. Actually, no, we're not. This has to be tightly packed. No white space allowed. Token dot, and then identifier. That's it. It's just an identifier. And actually, all we give back is the result of this, so we don't need to unwrap it. And instead of a string, this will be an identifier. Cool. So now, if we get to this point, we just need to increment all of these things. 3, 2, 1. Cool. So we have a vec of fields. What's the thing in Rust to push to the head of a vec? I can never remember. There's a function to do it, I'm pretty sure. Push. What are they? Leakland, push, reserve, resize, retain, splice, Rust, push to head. Is it insert? Yeah, insert. There we go. I don't know why I had to go through Google to land back on the same docs page to find this, but there we go. Shifting all elements after it to the right. So this has, bad complexity, but that's okay. Fields dot insert 0 ID. I think we need to make this mutable here, and then assign struct fields. Fields, that's fine, and then we'll call this RHS, and we'll call this RHS here too, because then that's better. And then we need to use this, so statement very. I think this maybe needs to go up here too. We'll do it in between these two. It's struct fields, and then when we build, everything should be fine. Identifier not found in the scope. That's because it's AST identifier. Assign struct fields. Assign struct field. Yeah, I guess it does make more sense as a singular, because ultimately we're only assigning to one struct field, even though there may be multiple fields that we have to walk through to get to the one field. Okay, so expected result identifier, confidence error, found parser error. Yes, because we need to do this with confidence. And as with all things, start with low confidence. Nice. Okay. Hold on. Then this needs to be outside of that. Beautiful, beautiful. Sigo Null, welcome. Catching a stream? Yeah, awesome, awesome. It's a slightly different time that I usually stream. I don't normally stream around this point. I'm usually like making dinner or eating, but I've got some friends coming over in 45 minutes and we're gonna go get a kebab. So it is, it's a more chill night. Okay, so what happens when I run this now? What do we get to? Assign struct unimplemented. Why? Why does that happen? Assign struct unimplemented. That's not what I expected to see. Because we're not assigning to a struct at any point. We're, God, sorry, I apologize. This is all a bit strange for people connecting, but essentially, I'm only really dealing with struct pointers. I'm not dealing with value initialization for locals. So if you want to make a struct, and there's also no malloc, but there's no memory protection either. So I'm making this test struct, and I'm just sticking it at a really random memory address, which, you know, it works. It works. Okay, so why do we get here? Why do we get here? CodeGen 282. 282. Oh yeah, because obviously we're actually trying to implement this. Okay, so fields and the right-hand side. Okay, what do we do to assign to a struct field? Well, that's a fantastic question. That's a really fantastic question. We're gonna start with the head. We're gonna say this is 0. We'll say fields. Will we? Will we do this? Let's say for field in fields. Okay. So for each field, we want to say. Actually, no, we want to start with the first thing. So we want to say, get the first thing. And we want to error if this isn't valid. And the compiler error we want to give back is probably not one we've written yet. What error is this? If we're trying to assign to a struct field, but we've not given it any... Well, I mean, you know what? I'm actually just going to panic here. I'm actually just going to unwrap, because if we get to this point, it's a parser error. This is a bad experience, but all of these unwraps... Essentially, I need to do an audit at some point, and every unwrap... or maybe expect, and then I can say this should, this is a parser issue. Okay, so we've got the first field. Now we can look up the type of that field. Can we? Yes. So we need to look this up as a variable, right? So the first one is a variable, but then after this, they're all recursive struct lookups. So we need to go context.get whatever this is. Context dot scope.get, sorry, scope.get head. Scope.get, it needs a context as well, my mistake. Context, nice. Okay, so let block variable, and a block variable, it would be nice to be able to just call getType and not have to unpack it, because in this instance, we don't actually care. Well, we do care. No, I don't like it. I don't like it. This is a lot of code fanning out. This is going to be a lot of code. Okay, here we go. This is a Herculean effort. So let's match. Can we match it? Scope.get. This should just return get. Returns an option. So again, we'll say okay or undefined variable, unknown type, unknown symbol, variable undefined. That's what we want. Variable undefined head dot to string. Beautiful. Okay. We'll question mark that. We'll match against it. Now, if it's a block variable local, this has an index and a type. But we can't use the word type as a keyword, obviously. So, block variable. Well, I mean, we can kind of see it here. Block variable local. IT, index type. Except we're treating these as pointers. So we get whatever local is at this index. That's a pointer into this type. That does work. It's not the most efficient way to do it, but it does work. So if we need a way of, we basically want to say if this is a struct or if this is a struct pointer. But long term, that may not be the condition we want. So let's maybe say if tie.isStruct or matched what's the best way to unwrap this? Because if it's a struct, then we go if let pointer, no, hold on, type pointer t equals ty. Except we want to do the same thing in both these cases, but we're just going to have to live with that. So otherwise it's not a struct, and we say return error, compiler error. And this is field reference on non-struct. Maybe it should be non-struct field reference with the name of the thing. My God, this is really getting meaty. Okay, so we need to go into error. I'm going to copy and paste this because I can't remember that many characters. Some of these, like, I'm being very specific with what these errors are, and I think that's good. I think that's a good thing in general. Okay, so if this is a struct, then what do we do? Let's step through this. So if it's a struct, we need to get the local. Now, we have a helper for this, maybe, or we should have a helper for this. We don't have a helper for this. We need to make this a helper function. We're going to do that right now. Get, maybe get local in register. Maybe we'll just call it this, right? And then we can pull these back maybe 7 indents. Oh, perfect. I love when you can eyeball the right indentation level. That makes me happy. So stack, we pop. Maybe that's not the right thing. If it's a local, we're assigning to it. CSP, why do we pop? Oh, because we just compiled an expression. Yes. This, what order do we do this in? If we have a dot, let's go to the right scene. If we have a dot x equals 72, right? Do we push 72 to the stack, then set up a register with the memory location of x, and then pop this into a register? And yeah, okay. So this is not the thing we want. This is the thing that assigns from the stack. to, from stack to store word. Yeah, where, from stack to local. Where we use where we do this. Yes, this is good. This is good. And it leaves B and C mangled, but that's okay. So, okay, we have assign from stack to local. We need assign from stack to arg. My God, this is gonna make sense. This is a good change. This is something I've needed to do for a while because there's too much duplication here. Assign, so local. So this is, yeah, writing to a local. This is writing to an arg. Cool. Oh, and we need to pass in the vec as well. We're gonna out, which is a mutable ref to a vec. And this should be okay. I think this is fine. Or do we just return? It's either that or return an array, but let's do it this way first. Out is a mutable ref to a vec of unresolved instruction. Cool, and this mangles some registers, and that's okay. That is okay. We accept mangling. So similarly, we need an option, a function that from stack assign from stack to arg, assign from local to arg. We need a function. That load arg to. Let's start with locals. Let's start with local to. Vec unresolved instruction index u8. Okay, this is good. This is what we need. So assign dref. Dref is okay. Oh, we want the expression version of this, yeah. Compile expression. Okay, here we go. So not literals. Literals, dereference, no. Address of. This is what we want. We want the address of. Oh, whoa, no, I'm on the wrong scene. No. Oh, God, that was such a long time. Where's Bobius when I need him? Disappointing. That's okay. I think I narrated well what I was doing. The concepts stand. I'm trying to move all these repetitive, horrible things into helper functions so that I can share the behavior, so that I don't have to copy and paste all the time, right? Because copy and pasting is bad. Copy and pasting is really bad. It's pretty bad. Okay. So, and this is good actually. This is very, very simple to get. So we can do this local index. This is going to take a register as well, right? And so we target just some random register we hand in, and that makes things a lot simpler. Out dot push cool. Then we do the same thing for arg as well. We say load local arg, load arg adder to, has the same shape, which is cool. They just live in slightly different places. Where was this? We want this adder of address of, cool, and we want this for an arg, and again this is pretty simple. I want to do this I want to push this back 6 indentation blocks, I guess. Out dot push, out dot push. Cool, cool, cool. And now this, we just use whatever register we pass in, which is kind of nice. Cool. Okay. This makes things a little better. There's a couple of problems here. There's a little bit of bad copy paste, and I think, oh no, that's okay. Yeah, there's a bit of bad copy paste. Okay, I'm just trying to think how much of this I can get done. Oh, I'm gonna rename these all to I think. Oh no, I'll rename this to index. I like the word index. Index is good. Expected string found. Expected strref found identifier. That's fine. Expected 2 fields found 1. Yep, because that's not wrapped in a tuple. We're pattern matching. We're destructing. Excellent. Helps if you actually build it. Things are not covered. Okay, good, 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 good. So you can see why having to do this for each thing. Like, it would probably be nice to be able to say, if this whole thing, if we can just reason out the type, we can do this check on the outside. Otherwise, we're going to have to do this is struct, is pointer, whatever, for each type of variable. And if we add a new one, then we have to do more copy paste again. Let me just resolve this by saying to do cool. Now, does this build? Yes. Does this run? Excellent. That's good news. That's good news. It doesn't do anything, but it runs. It doesn't generate any code, but it runs. That's a start. Okay, so let's look at address of real quick. And what I'm going to replace this with is load local adder 2. Load local adder 2. So this is gonna be a little more of a change than I thought. We're gonna put a curly brace in here, all right? We're gonna make a new vec. Out is vec new. We're gonna say load local address 2. We're gonna, what are the arguments to this? Ah, crap, I just overwrote my mark. Out index register load local address 2. Load local address 2, we take a mutable reference to out, we take the index of the local, which is I, and we take the register, which is register C. And then we push to out this one stack instruction, out.push. And then we return OK out. We're gonna do the same thing for the arg. We're gonna essentially copy and paste this block actually, except this now needs to be a curly brace. Gotta have the right bracket type. Cool, so we're gonna copy and paste this for arg. I like this a lot. This is feeling good, except this is load arg adder 2, but we still push it at the end. I think this is going to make the eventual cleanup when we stop doing everything via the stack a lot simpler, because we have this helper for load address 2, which is nice. This is a bit more inline. Okay, so assign struct field, we have a warning, 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 warning. Did that build actually fail? It did. What's the error? I expected U8 found usize. Okay. Expected U8 found usize. 518. We're just gonna cast it down. We're gonna cast it down. We're gonna accept this madness. This can run again, which is good. Okay. Again, it doesn't actually generate code for this, but it runs. We should be able to run these tests and they should pass, which is perfect. So it's good to have this good test suite where we can be pretty confident that we haven't broken stuff. That makes me feel good. I like it when I don't break things. So we can do this as well. Assign from stack to local. Assign from stack to arg, yeah. So let's go assign from stack to local. We're gonna grab the index, and this does not take a thing, a register. Excellent, and all these tests still pass, so that is good news. And again, we're gonna replace all of this code with a helper function. Assign from stack to arg. This is a little bit of a sidetrack, I will be honest, but it's gonna help. It's gonna help a lot. It's also gonna make this commit really hard to read, but it's gonna help a lot. So from stack to arg, we need a mutable reference to our output vector, and we need the index as u8. Something went wrong there. What was it? Global. Wait, assign. Arg. That looks okay. Where did this, have I lost a bracket? Oh, Sigo Null subscribes. Phenomenal, welcome. Thank you for being my first subscriber. That's really cool. I'm glad you're enjoying the show well enough to want to support it. That's awesome. Thank you so much. Thank you so much. I only turned on affiliate recently. I've had it sitting there for a while, and I've been on the fence about if I'd turn on the paperwork, but I'm like, yeah, let's do it. Let's see if anyone wants to support. So thank you very much. That's very heartwarming. Match BV. BV. We're matching against BV. Love the work. Yeah, awesome. I'm working on some emotes. I've tried to draw some myself. They're maybe not quite up to scratch. So I've been scoping out a couple of artists to pay for some cool emotes. There will be something good. My plan is to have a pixel art moth for bug. I think that'd be a fun one. I've got a few other ideas, but definitely a pixel art moth will be coming hopefully soon. But yeah, that's awesome. Cool. So what match BV? Okay. I see what happened. I see where the stray curly brace is. But yeah, I'm probably gonna do like a sub-only part of my Discord as well if you wanna, have a way into my ear about projects. As I did the paperwork for affiliate, and then I was like, oh crap, I've got to think about this. I've got to actually do stuff. But it'll be good. I'll make it a little bit more valuable than it currently is. But also, hopefully you find supporting me valuable as well. That is also cool. Okay, so if this is a local, then we are going to load local adder to local adder to. We're gonna build. We're just gonna do this vec new. We're gonna build a list of instructions. Oh no, we've already got out. Okay, so mutable reference to out. This isn't in a loop or anything, so this should be okay. Mutable reference to out and the index, which is going to be index as u8, and then we need to grab the other thing, which is the actual register. We'll put it in register C. Okay, so we're loading the local address. We're literally just going to copy paste this into this block. I kind of hate it. So we have the local address, and we know it's a struct. So then we need the offset of a field with that name. So the next thing, so we need a let mut field head equals 1. So we're going to say, oh, except this does need to be in a loop. This mutable reference might actually be a problem. Okay, we'll assume this only has length 2 for now. Let field equal fields dot get 1 dot expect. But I'm just desperate to get something working here, okay? Because otherwise it's going to be a bit of a flop stream. I want results. I want structs at least kind of working. I want to demonstrate it. So tie is a struct, and actually, oh no, we need to actually look this up as a field. So if let type struct fields, we'll call it maybe sf equals the type. We'll say sf.get field, the name of the field, and if it doesn't exist, so we'll say dot okay or compiler error, we'll say variable undefined for now, even though that's not actually correct. Field 02 string, and then we just deref that. So we're gonna say field field type and field offset. And I actually don't know if we need the, no, we do need the type. We need the type because we need to know if it's assignable. Gosh, who would have thought this was so complicated? Is there an open source README, open source repo for this? Yeah, github.com/phylum/rust simplevm. I don't have Nightbot set up. I am the Nightbot for this channel. But yeah, it's here. It's I don't think I pushed it yesterday, but it's pretty up to date. It doesn't have any of this stuff yet. Holy crap, I haven't pushed today. I don't want to leave this in too broken of a state. So that's fun. Tombot, yeah, exactly. I mean, I think that's what my bot in my Discord's called. Resolve, structural type, and a size. And an offset, sorry, which is represented by usize. Okay, so we have the type, we have the offset. Then we need to say if, oh, we need to get the right-hand side as well. So we actually need to do that first. We will compile the expression. We'll say out.append compile expression. I think we have to do this in 2 steps for some reason. I can't remember why. FEMEB. Which part is working? Front end, middle, and back end. Yeah, this, I'm doing very back end code generation right now. But, you know, I'm doing it all. This is like the language. So I'm basically trying to get this bit of code to work. Ignore the fact that I don't have a malloc or anything yet, so I'm just making up addresses for my pointers. There's no memory protection, it's fine. Memory protection, who needs it? It's overrated. Okay, I kind of lost my train of thought. We have the compiled expression on the stack now, so we also have the offset of the thing we need to write to. So if we also need the type of this expression. That's what we need. So let's say let RHS type equals type of RHS. I think we need to pass the context as well for that. Oh, what's the backend hardware? This is a programming language that targets my 16-bit virtual machine. So it's all me, all the way down to the metal, all written in Rust. Oh, okay. 12 minutes away. How long ago did my friend say that? He said that 5 minutes ago. I think I unfortunately might have to leave this in a bit of a jumbled, unfinished mess, which is kind of funny. But I don't know. I'll leave this alone and I'll come back to it tomorrow and hopefully do another nice long stream and get Structs working. But I think my brain is a little bit fried after 2.5 hours. I'm just going to leave this window open and then I'll come back to it at some point. Viranchi 12. Thank you very much for stopping by. I'm sorry you're just catching the end, but we will find someone cool to throw a raid on over to. Okay. Fairly productive stream, even though I didn't get everything done, but I knew structs would be big. And straight away, I'm looking at who I can raid, and someone's making an armored core clone in Godot. That sounds kind of awesome. So that's a top contender. Someone's doing some Vulkan. If anyone has cool recommendations for someone to raid, I'm always happy to take them. I love supporting other people doing cool stuff. Love finding people doing cool, weird stuff. Backend is hard to code. Backend is very hard to code. I also don't know what I'm doing. I'm just making it up as I go. How many viewers do I have? I feel like there's kind of like a socially acceptable, like, you know, I don't want to raid someone with too many viewers, with too few viewers, but Armored Core Clone in Godot sounds fun. Let's throw some viewers over that way. And it looks like they're actually taking a break, so that's kind of funny, but we'll throw the viewers over there anyway because the project sounds really cool. So maybe I'll just chat for another minute. just so we're ready. Everyone's ready to go across. I gotta go. I got a friend who's gonna be here soon. I need to do a quick like vacuum before they get here. So thank you everyone for stopping by. It's been a fun stream. We've done some good stuff, and there will be a second part to this where I actually get it working. Where's my backend compiler knowledge coming from? This is a fantastic question. I love when people ask me this. I'm going to take this one more question before I go. I'm literally making it up. You can find all the VODs for these streams on YouTube and on my channel. Let me link that in the chat real quick. But yeah, no, I'm making it all up. And that has reared its ugly head a few times, but it's been a fun journey, and I've learned a lot of stuff just by blindly failing forward. So once again, thank you all very much. Let's do this raid, even though this guy's away. Hopefully they'll come back and have a nice couple of extra viewers. Hope you all enjoy it. Thank you all so much. Bye.